This is a Python course 6, so if you're seeing this, since I missed a day, this will only be offered as a recording, and so there's no one here live. This is the last class in the summer program, and here we're going to be just reviewing everything, and then we're going to be talking about functions. So you can join the pair deck, but since we're not live, that's not important. So to follow along the code, go to your browser, type in free online Python compiler, choose one of the links, save any code that you write if you want to on a Google Doc so you can reference it later. So for example, I'll be using program is, and while this still has some code left over, this is where you can just type code and you can see the code, execute. So you can join the group me and join the Google Classroom, which isn't as important because this is the last lesson. So there will be some resources posted if you guys need be. So all right, so here's a review of everything we've done in this course. The very first thing we did in the first couple of days, we talked about print statements. Remember to write out print, followed by parentheses and then quotation marks. Comments, we have single line comments with the hashtag or the pound sign. And then we have triple apostrophes to denote multi-line commas. So you can comment out whole sections. We have this variable assignment statement. Remember, variable is equal to 10 here. And then we have expressions where you can modify the variable using a multiplication, addition, subtraction, division, etc. We went over Boolean values. So 1 is less than 3 is true. And we use if statements based on these Boolean expressions and Boolean statements to run different segments of code depending on certain actions the program has. And then our last class, we talked about looping, so for loops and while loops to do a certain action a certain number of times or until a certain condition is met. Okay, so we need to talk about functions in this class. So why do we even want to use functions? Like if we're adding just something unnecessarily complex for no reason, the reason why we want to use functions is because let's say we have an opening problem here. So the opening problem is to find the sum of integers from 1 to 10, from 20 to 37, and from 35 to 49, respectively. Okay, so normally how you would do this without the use of functions is that for each problem you would treat them as a separate problem, right? So for use like a loop from 1 to 10 by itself, from 20 to 37 by itself, 35 to 49 by itself. And what that results like is we're ending up with something like this, to be adding up the first one, adding up the second one, and adding up the third one. So you can see that this, although it does work, it's kind of cluttered and you're kind of reusing a lot of code. And so for specifically, if you take a look at these three sections, like this is pretty much the same thing. You're writing the same thing pretty much by only changing like the start index and the end index. So the solution is actually to declare a function. And so we're going to go into more syntax later, but basically, just assume that this just assume that we pass in two values and then we could run this code. And so this is what it results like if we use something called functions. And as you can see, it's a lot more complex, a lot more clean and concise, but although you do need to know like the function syntax. Okay, so how do we define a function? Okay, so a function is a collection of statements that are grouped together to perform an operation. So in basic syntax, the function header is you start with the def for all functions, and then function name. So a function name can be anything. It's aligned with your remember your basic Python naming conventions. Like you can't start with a number, but you can have a number in there, et cetera, et cetera. This name can be whatever you want to. And there's two things called formal parameters. So formal parameters are the two numbers you explicitly pass into the function. And then everything following this is like the code that you actually write, the statements, the expressions, the function body. And then importantly at the end, you need a return value. Well, you don't always need a return value, but usually you're gonna have a return value or you're gonna like terminate. So to actually call a function, you're just gonna write the function name, and then how many parameters you have, you're gonna pass in those parameters. So let's look at the function header more specifically. Remember I said the header begins with the def keyword, followed by the function's name and the parameters. And then remember for all functions and loops and if statements, you're going to have a colon. Then everything else is going to be indented. So the formal parameters, you can think of these as variables defined in the function header These are the formal parameters, and these formal parameters are going to be things that you pass in yourself through the invoking of the function. The actual parameters are the sorry, when the function is invoked, you pass the value to the parameter. This value is referred to the actual parameter or argument. So you're passing in these actual parameters, which then become formal parameters in the function. So return value. So a function may return a value using the return keyword. So sometimes, not always, you can use a return value. In this instance, we're returning the variable result, which is going to be set equal to z. So whatever max this and this will equal to is going to be z. Sorry, it's going to be equal to whatever the function returns. So here's how you call a function. So we have this function def of max num1 num2. And so basically, everything you write is in we would call a main function. So this is already written in there. You don't have to like do this. Like it's already given to you. I automatically assume that's a main function. So let's start. Give I equals to 5, j is equal to 2. So if you pass these in, first is 5, second is 2. Num1 is going to be equal to 5. Num2 is going to be equal to 2. And then if you use your same if statement, so if 5 is greater than 2, the result is going to be equal to number 1, which is 5. So we're going to return results. So k is going to equal to 5, and the maximum difference between 5, 2, and 5, the maximum difference between 5 and 2 is 5. Does that make sense? Okay. So we're going to trace this function entirely. Like I just gave a basic overview, but this should make it a lot better. So outside of everything, whenever you write code in here, is going to already notice that this is main.py. It's already going to call the main function. And then so if you write the main function, we start out about I as being 5, j as being 2, and then we're going to invoke max. So k is going to be equal to whatever this function returns. And what we can look into this is that remember what the actual value, actual parameters is I is j, I and j. Num1 will be equal to I, num2 will be equal to j. And this is basically based on position, right? If we switch j and I, this will be based on j, this will be based on I. So we're going to pass in the value of j to num1, and then the value of I to num1, and then the value of j to num2. And since now that we have these formal parameters, we're going to go into the function body. Like you actually use these numbers or actually run code that is in the function. So if num1 is greater than num2, which is true, since num1 is 5 and num2 is 2, we're going to return the result. Sorry, we're going to set result to the number 1, which is 5. And then since we already did one of the if else loop, we can skip everything else. Then we're going to return result, which is 5. So now k equal to max ij, which is 5. Then we're going to print out with all the variables, etc. And then we're going to return, and then that's it. So with functions, there's something called a call stack. Basically, every time you call a function, it's going to go into some sort of like memory storage so that your program knows which one to run first. So if the main function is invoked, first, we're going to set a heap for storing objects. You don't really need to know too much about what this is, but basically, somewhere in your program, it's storing the objects. And then if if the second function is called, then instead the max function is being executed. Like it runs on runs on these objects. So there's no space that required. It's just like these copy the values. There's no space that's required. Okay. So basically the max function is finished and returns a value which is sent to k. And then this is a heap for storing objects. It's still only 2 objects. And since the main function is finished, right, your program needs to handle memory correctly, and so it'll delete the stack. Like it'll clear the stack. A function does not return a value. So this is called the none value. So a function that does not return a value is known as a void function. In other programming languages, this is, let's say, Java, C++, and C Sharp. So you would usually call void function, but in Python, you don't really to say that. Instead, you can do def sum equals to number one, number two, total equals to number one plus number two, and then print the sum of that. Oop, this one actually doesn't work because you need to return a value. So here's going to be a more complicated topic. So this doesn't really apply when you're doing with just basic data types, but you're going to know, passing arguments by positions. So, okay. So suppose you want to invoke the function using in print line, welcome to Python 5. So the message and 5. So basically what this means is the output, I'm going to print the message, welcome to Python 5 times. Suppose you want to invoke the function using in print line computer science 15, computer science, and then repeat that 15 times. That's what the output's going to be. Then what's wrong? And then this one we're calling message equal to 4, range is equal to computer science. So actually this is going to be an error because you can't iterate up to a string. You can remember this index. This is an end index in the range. And the range call has to be an end index, which can only be like a number. So putting a string there is going to generate an error. Okay, so keyword arguments, make sure you're lining them up correctly. So if we're supposed to, if one of them is supposed to be a number, other one is supposed to be a letter, then we have to do that. Okay. And then this one, if you check this one, is this okay? Input line n equals 4 message equals computer science. You guys can try and see that on your compiler and see if that works. Okay. Okay, so I actually got a little bit confused. I thought pass argument by position was actually this one. So this is an important concept that isn't applied to data types that you learn in this course specifically, but every basic data types are passed by value. So in Python, like many other languages, is based on objects. So if you remember class 1, this is an object-oriented programming. A variable for an object is actually a reference to the object. So instead of actually being like the box itself in your memory program, you can think of it as like a pointer pretty much, or something that node tells your program where it is in storage, like an address basically. So when you invoke a function with a parameter, the reference value of the argument is passed to the parameter. So this is referred to pass by value. So for simplicity, we say that the value of the argument is passed to a parameter when invoking the function. Precisely, the value is actually a reference value to the object. If the argument number is a number or a string, the argument is not affected, regardless of the changes made to the parameter inside the function. So this can be quite hard for you guys to understand, but basically the idea here is that um, if you pass in a number to a function, say we pass in, sorry, if we go back, um, let's go back to this one. Okay, so if we pass in, no, not this one. Let's see, where's the first one? Okay, here it is. So just ignore all this like tracing stuff. So if we pass in 5 and we were to say add 1 to 5 in the function, if you return, I will still be equal to 5. It's not going to change this value of I outside of the function. And this is the true for ints and strings. So j, if you pass in j is equal to 2, and for instance, you've made like j times 2, made it multiply itself by 2, or you squared its value here, a j outside would still be 2. So this way, like this kind of makes sense, but in like more complex objects or data types, like you can be passing in a reference. So this both modifying this might eventually in the future modify the one you use in your main function. So just be careful of that. Okay. Okay. Yeah, and then we could take a look at this. For example, you can think of like x equals to 4, x is actually equal to the ID, this random number ID for the object, for the integer variable 4. And then y is also equal to x. It's going to also be the same thing as x, which is the same ID. And then whenever you actually modify y, it's going to create its own ID because instead of being 4, it's something different, it's 5. So that's just something to keep in mind. And finally, we talk about like the scope of variables. So a scope is the part of the program where a variable can be referenced. So a variable created inside a function is referred to as a local variable. Local variables can only be accessed inside a function. So the scope of the variables of all the scope of a local variable starts from its creation and continues to the end of the function that contains the variable. In Python, you can use global variables. They are created outside of all functions and are accessible to all functions in their scope. So what this means is if we go back to this example, result here is created in this function. If we wanted to access it outside of this function, this specific function by saying maybe like print out result in this main function, it will generate an error because result only exists in this max function. So this variable here only has a scope that's limited to the max function. So if you try to reference it outside, it's going to generate an error. And then we can give some examples. So here's a global variable. You can notice a global variable because it's declared outside of all functions. And if we call this variable f1, we print out the global variable of 1, then the local variable of 2. But if we then print out global variable, you can go, it still be 1 because it's declared outside. But if we print out local variable, since it's only declared in this function, at the end of the function, it'll get like deleted in memory. It'll get like glossed over pretty much. So this is out of scope, and this gives us an error. Example 2 is giving f1 equals, we're resetting global variable equal to x equals to 2, printing out x, it displays 2. But then once we exit the function, remember x is still equal to 1 to this other function. It's only in this function will be equal to 2. Or print out x, which displays 1. Okay, so example 3, x equals to eval input enter a number. So basically what this line of code does is it takes an integer input. If x is greater than or equal to 0, y equals to 4. And we're printing out y. This gives us an error if y because y is not created. So the only line here where y is assigned is if x is greater than 0. So y equals 4. So imagine we go through this code and instead of entering in a positive number, we enter in a negative number. Y will never be created, and thus we are printing something that does not exist. And this is why this is an error if y is not created. So this is like a scope error as well. So a simple way to fix this would be maybe put y equals to 0 outside of this, and then only set y equals to 4 into this assignment statement if it x is greater than 0. So the benefits of function, right? We got to all of that syntax. And so what is the benefit of a function? So we're going to write a function once and reuse it anywhere. That way you don't have to write the same code over and over again. And two, the main thing here is in the higher level programming is that you can hide information. So for specific for like so in general, you want the user to have access to as little information as they need, like only what they need to have like their main functions, like only what they need, only give them the information they need to complete their tasks. Like you don't want them to have access to extra things. So by using functions and doing lots of local variables or private variables, you can hide like sensitive information, like how your code works and implementations from your user. And just in general, it just reduces the complexity. It makes it a lot easier to read, a lot easier to debug. You can quickly check if the function is working rather than a bunch of code in just your main function. Yeah. So we have a couple of exercises here. Exercise 1 is to write a function to print out a message 5 times. And then with that function, we're going to call that function 3 different times with 3 different messages. So the first function call, you're going to be printing your name 5 times. Second one, your hobbies 5 times. Third message is your goals. So I'll give you some time to do that. Okay, and then you can pause here for more time since this is a recording, but I'll just go ahead and do this. So the first part is to write a function to print out the message 5 times. So we're going to def print 5 times. And then we need to be passing in the first, sorry, a parameter of message every time. And we can do this by using a for loop. So if you remember last class, for I in range of 5, this makes it so we print out 5 times. And to print message. This is a basic function implementation. So remember we're passing the message, which can change every time. Let's define a main function, which we're going to print 5 times. First one was my name, so I'll put Ethan. And then, because I'm lazy, I'm going to copy and paste this. So hobbies, one of my hobbies is swimming. And then the last one is some of my goals to be successful. And if you see if I wrote, they need to call the main function. Now, you can see it's pretty self-explanatory. It's pretty well done. Another thing, important thing to note here is if say for instance I declare this function behind, going to generate. Oh, what's not? Never mind. But it's just common practice to put the function above where you actually call it. Okay, that's pretty neat. Second exercise to create a function that finds the square root of a number and call this function 5 times with different input numbers. And remember to receive an integer input, use the following code. Int input. Just remember this code. I'll give you some time. Okay, you guys can pause if you need to, but let's go ahead and write this. So create a function that finds the square root of a number. So number 2 def square root given a number of x to return x 0.5. Remember that's the square sign. You square a number by 1/2. That just finds the square root. So we're going to def a main function. Remember how to input a variable into input. So x goes to, sorry, let's use different variable number to int input. And then we're going to square root x square root number. Print square root of number. Then we want to do that 5 times. So the way we can do that is so for I in range of 5, when we indent this code, should work. Then we go to main, just call the main function at the end of this, run. Okay, first number 3, second number 2, and then let's do a perfect even square of 5. Well, we can do more, so 64, 3, I already did that. Yeah, so remember your square root function, pass in the integer value x, return x square root. This is how you simply do that, which is square it by its half. Def a main function, since we want to do it 5 times, for loop 5 times, and then inside number, which is an input integer, and then going to print out what this function returns, and then call the main function again. Okay, so that's it for this summer camp. There's some outside resources if you guys want to learn. Codecom has a great resource for you guys just to play. It's really fun.